The history of the Triceratops. Explore the world of the Triceratops, an iconic Cretaceous dinosaur known for its 3 horns and its impact on science and culture. Through the discovery and study of this magnificent herbivore, we have gained valuable insights into the era of the dinosaurs and their ecosystems. Dive into the history and legacy of the Triceratops, and discover how it continues to inspire the exploration of the prehistoric past. Chapter 1: The Discovery of the Triceratops. In the late 19th century, the world of paleontology experienced one of its most emblematic moments with the discovery of the Triceratops, a giant that once walked the Earth during the late Cretaceous period. This fascinating creature, whose name means three-horned face, was unearthed in what is now North America, uncovering not only its imposing bones but also a hitherto unknown chapter in the natural history of our planet. Othniel Charles Marsh, a prominent paleontologist of the time, played a crucial role in the identification and naming of the Triceratops in 1889, marking a milestone in the field of paleontology and sparking public and scientific interest in dinosaurs. The search and excavation of Triceratops fossils revealed a creature of astounding proportions, endowed with 3 prominent horns and a large bony frill, features that immediately captured the imagination of scientists and enthusiasts alike. The magnitude of this discovery not only provided crucial evidence about the diversity of prehistoric life but also spurred debates and studies on the biology and behavior of dinosaurs. The scientific impact of finding the Triceratops was monumental, extending the boundaries of human knowledge about the Mesozoic era and providing an invaluable window into the past. In those days, paleontology was in its infancy, and each new discovery was a treasure trove of information that challenged existing perceptions. The appearance of the Triceratops on the scene not only added a fascinating species to the fossil record but also stimulated fierce competition among paleontologists, known as the Bone Wars. This rivalry, mainly between Marsh and Edward Drinker Cope, drove the exploration and discovery of fossils at an unprecedented pace, significantly enriching the understanding of prehistoric life. The excitement surrounding the discovery of the Triceratops reflected the awe and curiosity inherent in scientific exploration. The Triceratops' ability to inspire generations of scientists, enthusiasts, and dreamers underscores the importance of these discoveries in shaping our understanding of the natural world. As more fossils were unearthed, the image of the Triceratops became clearer, promising new adventures in the study of ancient life and reminding us of the perpetual wonder of scientific discovery. Chapter 2: Anatomy of the Triceratops. The anatomy of the Triceratops is a testament to the uniqueness and evolutionary diversity of dinosaurs. With its imposing set of 3 horns and a large bony frill adorning its head, this giant herbivore possessed distinctive features that set it apart from other dinosaurs of its era. The 2 long horns above its eyes and a shorter horn on its nose served as powerful tools, not only in defense against predators, but possibly also in mating rituals and in intraspecific competition for dominance. The frill, a bony extension of its skull, is equally fascinating, offering protection for its neck and potentially serving as an impressive visual display among members of its species. In addition to its impressive head, the body of the Triceratops was adapted for a life of foraging. With a sturdy body supported by 4 strong legs, it was well equipped to support its massive weight. Its tail, which is relatively short in comparison to its body, and its semi-quadrupedal posture indicate a body structure designed for stability and mobility in the dense forests and plains where it sought its food. The details of its anatomy reveal more about its lifestyle. For example, its dentition was composed of hundreds of teeth arranged in columns that were continuously replaced, allowing it to efficiently chew tough vegetation. This complex dental system underscores its role as a dedicated herbivore, capable of processing a wide variety of plants. Exploring the anatomy of the Triceratops offers us a window into the past, showing how this dinosaur was perfectly adapted to its environment. Every physical feature, from its imposing horns to its robust body structure, not only served practical purposes in its daily life but also reflected the evolutionary and ecological pressures of its time. Studying the anatomy of the Triceratops allows us to appreciate the complexity of prehistoric life and the intricate pathways of evolution, highlighting nature's ingenuity in creating life forms adapted to their environment in unique and fascinating ways. Chapter 3: The Habitat of the Triceratops. During the late Cretaceous period, approximately 68 to 66 million years ago, the Triceratops inhabited what we now know as North America, in a world that differed drastically from ours. This imposing herbivorous dinosaur roamed landscapes dominated by vast plains and dense forests, a rich and diverse ecosystem that provided the perfect setting for the life of the Triceratops. At that time, the climate was warmer and wetter than today, which favored the growth of various plants, from conifers to ferns and cycads, essential for the Triceratops' diet. This environment offered not only abundant food resources but also challenges, including competition with other herbivores for vegetation and the constant threat of predators. The composition of the contemporary flora and fauna suggests that the Triceratops shared their habitat with various other dinosaurs, including gigantic sauropods and fierce theropods, creating a complex ecological dynamic. This context of coexistence and competition would have influenced the behavior and evolution of the Triceratops, adapting to both the abundance and threats of their environment. The Triceratops' adaptation to their habitat can be seen in their morphology and behavior. Its sturdy legs and low-slung body were well adapted to navigate through dense forests and open areas, searching for the most nutritious plants. The structure of its mouth and teeth, perfectly designed for chewing tough vegetation, indicates a specialized diet that took full advantage of the plant resources available in its environment. These physical characteristics, along with its social behavior, which some studies suggest included living in herds, could have been crucial for its survival and success in these diversified ecosystems. The Triceratops' habitat, with its rich biodiversity and complex ecological interactions, was a world of opportunities and challenges. Understanding this environment enriches our comprehension of the Triceratops and offers insights into the late Cretaceous ecosystem as a whole. Through the study of its habitat, we can glimpse the life of this fascinating dinosaur, masterfully adapted to its world, a testament to the incredible ability of life to flourish in a multitude of forms and environments. Chapter 4: The Diet of the Triceratops. The Triceratops, an iconic herbivorous dinosaur of the late Cretaceous period, is distinguished by its impressive morphology, which played a crucial role in its feeding habits. Fossil evidence, particularly the analysis of its dentition and the wear on its teeth, provides us with a window into the diet and feeding behaviors of this prehistoric giant. The teeth of the Triceratops were arranged in rows of dental batteries, capable of continuously replacing themselves throughout their lives, allowing them to efficiently process a wide variety of vegetation. The flora of the late Cretaceous offered a bountiful buffet for the Triceratops, including ferns, cycads, ginkgos, and the first flowers, which began to diversify during this period. The structure of its beak, similar to that of a parrot, allowed it to pluck the toughest leaves and branches, while its powerful jaws and teeth were designed to crush fibrous plant material. This combination of features suggests a varied and specialized diet, optimized to exploit the plant resources available in its environment. Moreover, the study of coprolites, fossilized feces, attributed to Triceratops, and carbon isotope analysis in the bones have provided further evidence about its feeding. These studies indicate that the Triceratops consumed a wide range of plants, including those with high fiber content, confirming their role as a dedicated herbivore. The ability to digest various vegetation was not only crucial for its individual survival but also positioned it as an important consumer within the food chain of its era, influencing the structure and dynamics of the Cretaceous ecosystems. The diet of the Triceratops reflects a sophisticated evolutionary adaptation to its environment, allowing it to thrive in the varied ecosystems of the late Cretaceous. These feeding habits, in turn, offer insights into the ecology of dinosaurs and prehistoric ecosystems, revealing how interactions between different species and their environment shaped the natural world of the dinosaur era. The study of the Triceratops diet not only enriches our understanding of this particular dinosaur but also contributes to our general knowledge about life on Earth millions of years ago. Chapter 5: Behavior and Social Life. The study of the behavior and social life of the Triceratops offers a fascinating glimpse into the complexities of the lives of these prehistoric dinosaurs. Based on analyses of wear patterns on the horns, battle scars on their bony frills, and the distribution of their fossils, scientists have begun to theorize about how these imposing herbivores interacted with each other and with their environment. These evidences suggest that the Triceratops may have had more complex social behaviors than previously thought, including the possibility of living in herds or social groups. The idea that the Triceratops could have lived in herds is supported by the discovery of several individuals in the same area, indicating that they might have moved together, possibly to search for food or protect themselves from predators. This group's existence would have had numerous advantages, such as increased efficiency in finding food and better defense against predators, particularly against the feared tyrannosaurs. Moreover, the presence of horns and frills not only served as defense but could also have played a role in social interactions, such as establishing dominance and courtship. The interpretation of these anatomical features and fossils has led some scientists to speculate about mating rituals and competition among males, similar to those observed in modern animals with prominent physical features. The horns, in this context, could have been used in ritual combat to impress potential mates or deter rivals, a behavior that underscores the complexity of their social lives. Furthermore, the analysis of wear patterns on the horns suggests that these were not only used against predators but also in interactions among Triceratops, possibly in the struggle for resources or mates. These interactions, far from being merely aggressive, could have included the formation of social bonds and cooperation, fundamental aspects for the survival of any species. Although much remains to be learned about the social life of the Triceratops, the available evidence points towards a group existence and complex social behaviors. This focus on their behavior not only enriches our understanding of these ancient animals but also offers a broader perspective on the evolution of social behaviors in the animal kingdom. The possibility that the Triceratops shared behaviors similar to those of contemporary social animals highlights the continuity of life across the ages, revealing patterns and strategies that transcend time and species. Chapter 6: The Triceratops and Their Predators. The relationship between the Triceratops and their natural predators during the late Cretaceous period is a fascinating narrative of survival and adaptation. Among the most fearsome adversaries of the Triceratops was the Tyrannosaurus rex, a predator of colossal proportions that dominated the prehistoric landscape. The interaction between these two colossal creatures has captured the imagination of both scientists and the public, evidencing a complex ecological dynamic in which prey and predator were exceptionally adapted to each other. The physical characteristics of the Triceratops, especially its three prominent horns and its massive bony frill, not only served as distinctive elements but were also fundamental for its defense. These anatomical traits offered protection against predator attacks, allowing the Triceratops to confront their adversaries with a formidable barrier. The arrangement and size of the horns, capable of inflicting serious wounds, along with the bony shield of their frill, suggest that the Triceratops were well equipped to deter or even combat the most formidable predators. Fossil evidence, including bite marks on the bones of the Triceratops that match the teeth of the T-Rex, provides direct testimony of these predator-prey interactions. Such findings indicate not only occasional encounters but possibly frequent confrontations between these species, illustrating an evolutionary battle in which both predator and prey continually adapted their survival strategies. The dynamic between the Triceratops and the T-Rex was likely more complex than can be simplified in terms of hunter and hunted. The social behavior of the Triceratops, if they lived in herds, as some theories suggest, could have provided them with an additional advantage, allowing them to collectively defend against predators. This cooperation, combined with their physical defenses, underscores the adaptability and resilience of the Triceratops in a world where survival depended on cunning and strength. Furthermore, the presence of the Triceratops significantly influenced the ecosystem dynamics, acting not only as a food source for predators but also as a regulator of vegetation through its feeding habits. This balance between the Triceratops and its natural predators is a vivid example of the interdependence between species, where each plays a crucial role in maintaining the health and diversity of the ecosystem. The relationship between the Triceratops and their predators reminds us of the complexity of life in the late Cretaceous, a time of giants whose existence was marked by constant challenges and adaptations. Studying these interactions not only provides us with a more profound understanding of these magnificent creatures but also offers valuable lessons about the intricate nature of ecosystems and the evolution of life on Earth. Chapter 7: The Mystery of Extinction. The extinction of the Triceratops, along with the disappearance of the dinosaurs in general, represents one of the most fascinating mysteries in natural history. Approximately 66 million years ago, at the end of the Cretaceous period, a catastrophic event marked the end of the era of dinosaurs, including the Triceratops. Theories about this mass extinction event have evolved over the years, with a scientific consensus emerging that points to the impact of an asteroid as the primary catalyst, although other factors, such as volcanic activity and climate changes, may also have played significant roles. Evidence of the asteroid impact is found in the iridium layer, a rare element in the Earth's crust but abundant in meteorites, found in sediments around the world corresponding to the time of the Cretaceous-Paleogene boundary. This discovery, along with the Chicxulub crater in the Yucatan Peninsula, provides compelling evidence of a catastrophic impact that would have triggered a series of devastating environmental events, including global wildfires, tsunamis, and a nuclear winter that darkened the sun and dramatically cooled the planet. This global cooling, along with the disruption of food chains and ecosystems, would have been particularly detrimental to dinosaurs, including the Triceratops, which relied on a relatively warm climate and an abundance of vegetation for their survival. Additionally, intense volcanic activity, particularly in the Deccan Traps region of India, could have contributed to the extinction by adding large amounts of gases and ash to the atmosphere, exacerbating climate change and ocean acidification. However, the debate continues about the exact role of these factors and how they interacted to cause the mass extinction. Some scientists argue that biodiversity was already declining due to environmental changes before the asteroid impact, which could have made ecosystems more vulnerable to a catastrophe. The extinction of the Triceratops and dinosaurs, in general, marks a turning point in Earth's history, a reminder of the fragility of life and how catastrophic events can drastically reshape life on our planet. Through the study of this period of extinction, scientists seek not only to understand the past, but also to extract lessons that may help us face future challenges in our environment. Chapter 8: The Triceratops in Popular Culture. Since its discovery in the 19th century, the Triceratops has captured the public's imagination, becoming one of the most iconic and recognizable dinosaurs in popular culture. Its distinctive silhouette, characterized by 3 horns and a large bony frill, has made it a protagonist in a wide variety of media, from literature and film to video games and toys. This omnipresent presence reflects not only the human fascination with dinosaurs, but also the special role the Triceratops plays in our cultural interpretation of these prehistoric creatures. In cinema, the Triceratops had memorable roles in numerous dinosaur movies, perhaps most notably in the Jurassic Park franchise. These portrayals have varied from being a majestic, peaceful creature to a fierce contender in battles against other dinosaurs, including the Tyrannosaurus rex. Through the magic of cinema, generations of viewers have been able to experience close encounters with the Triceratops, fueling curiosity and awe for the dinosaur era. Children's literature and educational programs have also embraced the Triceratops as a central character, using it to teach kids about prehistory in an accessible and entertaining way. Its image has adorned countless books, educational posters, and cartoons, each contributing to its status as one of the dinosaurs most beloved by the young public. Moreover, the Triceratops has been a favorite among collectors of fossils and dinosaur replicas, with replicas of its horns and skeletons occupying a place of honor in museums and private collections around the world. Its popularity has led to a constant demand for Triceratops-related merchandise, from toys and models to t-shirts and room decorations. The enduring presence of the Triceratops in popular culture not only demonstrates the enduring fascination with dinosaurs, but also how these prehistoric creatures continue to inspire, educate, and entertain. The Triceratops, in particular, with their distinctive appearance and place in the paleontological narrative, serves as a bridge between the past and the present, inviting people of all ages to explore the rich and wonderful world of prehistory. Chapter 9. Recent advances in its study. The study of the Triceratops has entered a golden age thanks to recent advances in technology and scientific methodology. These advances have shed new light on the biology, ecology, and evolution of this iconic dinosaur, significantly expanding our understanding of its place in the prehistoric world. From DNA analysis to advanced imaging technologies, scientists are unraveling the mysteries of the Triceratops with unprecedented precision. Paleogenomics, the study of ancient genomes, has begun to offer clues about the evolutionary relationship between dinosaurs, including the Triceratops, and modern birds, their closest living descendants. Although direct analysis of dinosaur DNA remains challenging, advances in this area promise to revolutionize our understanding of dinosaur genetics and their biological diversity. Moreover, scanning and 3D modeling techniques have allowed researchers to examine Triceratops fossils in more detail than ever before. These non-invasive methods have revealed intricate bone structures and enabled the virtual reconstruction of complete skeletons, providing new insights into the anatomy, posture, and movement of the Triceratops. Such technological advances have been crucial for understanding how this dinosaur moved through its environment and interacted with other organisms. The use of stable isotopes in the study of bones and fossil teeth has shed light on the diet and migratory behavior of the Triceratops. These analyses can reveal feeding patterns and even possible seasonal migratory routes, offering a window into the daily life of the Triceratops and their adaptation to the changing climate of the late Cretaceous. Additionally, research on bone pathologies and healing patterns in Triceratops fossils has provided evidence of diseases, injuries, and the animal's ability to recover. Such studies not only speak to the harshness of life in the Cretaceous, but also to the complexity of the ecosystems in which the Triceratops lived. These recent advances in the study of the Triceratops have not only enriched our understanding of this specific dinosaur but have also contributed to the general knowledge of dinosaur paleobiology. As science continues to advance, it is likely that future discoveries will reveal even more about the fascinating life history of the Triceratops, keeping alive the curiosity and wonder for these magnificent creatures of the past. Chapter 10. The Legacy of the Triceratops in Paleontological Science. The legacy of the Triceratops in paleontological science transcends its fascinating anatomy and place in the Cretaceous ecosystem. Over the years, the continuous study of this iconic dinosaur has played a crucial role in the development of paleontology, driving methodological and theoretical advances that have enriched our understanding of the prehistoric past. The research on the Triceratops has illuminated aspects of dinosaur evolution, extinction, and ecology, offering valuable lessons about the history of life on Earth. Since its discovery in the late 19th century, the Triceratops has been a subject of constant study that has stimulated the development of new excavation, preparation, and fossil analysis techniques. Its prominent presence in the fossil record has provided an abundant source of data to test hypotheses about the dynamics of Mesozoic ecosystems, species interactions, and patterns of growth and development in dinosaurs. Furthermore, the Triceratops have been central to the debate on morphological variability and speciation in dinosaurs, questioning how scientists classify and understand biological diversity in the fossil record. The discussion on the identification of species and the nomenclature of the Triceratops has contributed to broader debates on dinosaur taxonomy and the interpretation of anatomical variability across geological time. The Triceratops has also played a role in popularizing paleontology, serving as a bridge between the scientific community and the public. Its image has captured the imagination of generations, fostering public interest in the science of fossils and Earth's history. This fascination has supported fossil conservation efforts and underscored the importance of paleontology in scientific education and environmental awareness. The legacy of the Triceratops in paleontological science is, therefore, multifaceted. It has not only contributed to the advancement of scientific knowledge but has also played an important role in scientific culture and education. As paleontologists continue to explore the secrets of this ancient giant, the Triceratops remains a symbol of human curiosity and our constant effort to understand our world and its history. Ultimately, the Triceratops is not just a relic of the past but a catalyst for the future of research and education in paleontology.